If you work in electronic access control, you may have come across statements like, "I'm using a 26-bit card ID," or "Please specify the bit length and facility code in your card order." You may also have a screen on your computer software that asks you to select your card format or enter your facility code. All of these terms are trying to get at one thing: how should the system interpret the information on the card? When you hold up a card to a reader, the reader's job is to read it off the card and send it on to the access system. What you might not know is, the number doesn't always look the same way on every card. And it's often more than just one number. In fact, most of the time, it's two. So let's explore some ways that numbers are stored on cards and how that relates to terms like 26-bit and facility code. For just a minute, we have to get a little technical, so hang in there. Look at this number. You probably know what number it is. In fact, you recognized it so quickly and are so used to reading numbers, you probably forgot how you actually do it. Back in grade school, your teacher taught you about the ones place, the tens place, the hundreds place, and so on, and you practiced adding up the numbers in each place. So this number is 1017 because there's a 1 in the thousands place, a 0 in the hundreds place, a 1 in the tens place, and a 7 in the ones place. You recognized and added all that up instantly in your head. This kind of counting is known as base 10 because every time you move over a place, you multiply by 10, and because you use 10 different numbers, 0 through 9. Computers use a different counting system called base 2 or binary, which means that every time you move over a place, you multiply by 2. So, this is the ones place, and this is the twos place, the fours place, the eights place, and so on. Also, you only use two numbers, 0 and 1. So when we look at the binary number 1101, we do the same routine as we did in grade school. There's a 1 in the eights place, so that's 8, a 1 in the fours place, so that's 4, a 0 in the twos place, so that's 0, and a 1 in the ones place, so that's 1. 8 plus 4 plus 0 plus 1 equals 13. To a computer, 1101 is the number 13. To be more precise, 1101 and 13 are the same number. One is written in binary and the other is written in decimal. In computer science language, each digit in this number is called a bit. So this number is a 4-bit number. It has 4 bits. An 8-bit number would be 8 bits long, and a 26-bit number is 26 bits long. Now that you know how to count in binary, you could figure out what number a 26-bit stream of digits is equal to, but we have computers for that. When a 26-bit card is held up to a reader, something like this is sent to the access control system, a stream of digits 26 bits long. The actual ID number isn't all 26 of these bits though. It breaks down a little bit. The bit at the beginning and at the end aren't used for the ID number. They're more just for the computer. You can think of them as hello and goodbye bits. Bits 2 through 9 are for the facility code, and bits 10 through 25 are for the ID number. The facility code is 8 bits long, and the ID number is 16 bits long. 16 bits is pretty large. It means that the largest number, all ones, is 65,535. That's a lot of card holders in your access system. The question you might have now is, why is there a facility code? What's that for? It's to differentiate between two people with the same card ID. Let's say that two companies merge together. Alice works for company A, and Bob works for company B. Both companies use 26-bit cards for their employees. Alice and Bob's cards could both have the same ID number stored on them, but Alice's card may have a facility code of 25, and Bob's might have a facility code of 50. The access system can differentiate Bob from Alice because their facility codes are different. So that's the 26-bit card format. 8 bits for facility code and 16 bits for the ID. The 26-bit format is so common that many access control systems are set up automatically to read it. Now that you know that cards can have two different numbers stored on them, you're also ready to know that 26-bit is not the only card format. In fact, there are many different card formats out there, some common, some unique to individual companies. Some card formats have 3 or more sections in the bit stream to store different numbers for different reasons. Other card formats have all bits, except for the first and last, dedicated to just the ID number. So, a 35-bit format with 33 bits for the ID number could provide 8.5 million unique cards. For more information about credentials, visit our website at us.allegion.com or see the description below for a link to the Schlage Credential How to Order Guide.